Today we're going to continue adding and subtracting fractions with unlike denominators. We're going to add in some negatives, so we'll be reviewing our integer addition and subtraction, and then we're also going to have a few mixed numbers so that we can learn how to incorporate those in our problem solving. So the first problem, 7 over 8 plus negative 2 over 5, we have to find the common denominator between 8 and 5. We know that the LCM is 40, so we can use that. Now we rewrite the fractions using the LCD of 40. We're going to want equivalent fractions. So what we end up with is multiplying the first fraction by 5 over 5 and the second fraction by 8 over 8. Notice that the fractions we chose are equivalent to 1. This allows us to maintain the identity using the identity property of multiplication so that the original fraction is equivalent to the new fraction, and they both have a denominator of 40. So 35 over 40 plus negative 16 over 40. Now we write the sum over the lowest common denominator, 35 plus negative 16. Remember our integer rules, the signs are different, we will subtract, and we'll keep the absolute value, the sign of the one with the highest absolute value, so that would be the positive number. 19 over 40, and we don't need to simplify. Let's try another. If we have 3 over 10 minus 5 over 6, looking for the lowest common denominator between 10 and 6. Remember, you can use a ladder if you're not sure. The lowest common denominator is 30, so we'll multiply the first fraction by 3 over 3 and the second fraction by 5 over 5, so that our new fractions are in the form of 9 over 30 minus 25 over 30. Now write the sum over the LCD, and in this case it's a difference, but we know that subtraction is really adding the opposite of the next number, so we could rewrite this so that we can show it as 9 plus the negative 25 all over 30. And now we know that we have different signs. We will subtract the numbers and keep the one with the highest absolute value, which in this case is the negative number. So now we have a negative 16 over 30. But I notice that they both have a factor of 2, and I can divide out the factor of 2 and simplify to get a negative 18 over negative 8 over 15. Let's try another. 3/4 minus a negative 9/10. So a common denominator would be 20 because the LCD of 4 and 10 is 20. So I multiply my first fraction, 3/4, by 5 over 5. My second fraction, negative 9/10, by 2 over 2. Now let's write the sum, or difference, over the common denominator. So 15 minus the negative 18. Now remember that in this case I have two negatives. So subtraction I want to change to addition and take the opposite of the next number. So taking the opposite of negative 18 is a positive 18. So you could do that and show your work by changing both to positive or by adding a negative. However you want to do that, to know that this becomes 15 plus 18. Now they're both positive. I add them and keep the positive. When I get done, I have 33 over 20. I will want to change that to a mixed number. The way that we do that is take 33 and divide it by 20. Goes in one time, and when I subtract, I get 13. That's my remainder. I will write my remainder over the denominator. So I have 1 and 13/20 as my solution. Negative 4 over 33 minus 1 over 11. Now in this case, my lowest common denominator is 33. So I only have to rewrite one fraction. So that means I want to multiply the second fraction by a fraction equal to 1, that is 3 over 3. So when I have my fractions with a common denominator, I have a negative 4 over 33 minus a 3 over 33. I can write the sum or difference over the lowest common denominator. Negative 4 minus 3 is the same as negative 4 plus negative 3. So remember that when you see subtraction, you want to deal with it so that we can deal with the integers. Negative 4 plus negative 3 is negative 7. And I write that over 33. In this case, I'm going to take 5 3/5 minus 7. Now I already know that I'm taking a number away from something that's bigger. So I think that my answer is going to be negative, because if I try to take 7 away from 5 and a little bit more, okay, it's going to be negative. So I'm going to highly recommend when we start working with mixed numbers and some things become negative, that you should probably change it to an improper fraction. The way that we change 5 3/5 to an improper fraction is that we will multiply these two numbers right here, and then add in that numerator that was our remainder. So 5 times 5 plus 3, and that's all going to be over the denominator of 5. So 25 plus 3 is 28 over 5. Since I know that I have a denominator of 5, I want my second number then to have a denominator of 5. All whole numbers are fractions over 1, which means I can multiply this second fraction by 5 over 5 to get 35 over 5. So it's important that we have that common denominator. Again, writing my sum, 28 minus 35 all over 5 is the same as adding a negative 35. So now I have a positive 28, a negative 35. I'll find the difference, which is 7. It'll be negative because of my higher absolute value with negative 35. And my last step will be to convert it back to a mixed number. So 5 goes into 7 once there are 2 remaining over 5. I have a recipe, and it's going to call for 2/3 cup of white flour and 2 1/5 cups of whole wheat flour. How much flour do I need in total for my recipe? Now, you can take your mixed number and change it to an improper fraction, but in this case we really don't have to if we just deal with the fraction parts, because I'm not worried about the negatives. So we want a common denominator between the 3 and the 5, and it's going to be 15. So this one is multiplied by 5 over 5 to give me 10 over 15, and this is going to be multiplied by 3 over 3. Notice that when I do this, the whole number part of the mixed number does not change. And when you're adding with mixed numbers, and we'll work on this a little bit more tomorrow, you can group together the whole numbers and then group together the fractions. So there is no whole number with the first fraction, so my answer will just be 2, and then I'll add together the 10 and the 3 to get 13 over 15 cups of flour. And I cannot reduce because there's no common factors between 13 and 15. Now we're going to watch a couple videos that'll show you how to use some mixed numbers and grouping in case your answers become very large.
In this lesson, you will learn to add mixed fractions with unlike denominators by converting fractional parts to common denominators, regrouping fractions into whole numbers, and simplifying answers using greatest common factors. You know that the whole number and fractional part of a mixed fraction can be thought of separately. For example, 4 and 5/9 can be thought of as 4 plus 5/9. This expansion of a number is much like the separating of place values, as in 63 equals 60 plus 3, or 1 2/10 equals 1 plus 2/10. I'm going to explain the idea of adding mixed fractions with regrouping using an example with common denominators. 4 and 5/9 plus 6 and 7/9. If we are using the regrouping method of adding fractions, We stack them on top of one another to create a sense of place value. Here are the whole numbers, and here are the fractional parts. We add from right to left so we can regroup, just like most times we are adding by place value. 5/9 plus the 7/9 is actually going to give us 12/9. We know that 9/9 equals 1, so 12/9 actually equals 1 and an extra 3/9. We will leave the 3/9 in the fractional place and regroup the whole number 1. 1 plus 4 plus 6 is 11. Now we must simplify our answer using the greatest common factor. The greatest common factor of 3 and 9 is 3. So we will divide both the top and bottom by 3. This is the same as dividing the top and bottom by the number 1, which the identity property of division tells us this does not change its value. Therefore, 11 and 3/9 is equal to 11 and 1/3. Our final answer is 11 and 1/3. Let's see how the addition with unlike denominators works. We will need to convert the fractional parts to common denominators, regroup the fractions into whole numbers if necessary, and simplify our answers using greatest common factors. Mark has 18 3/8 cups of soda and 23 3/4 cups of fruit juice to combine for punch. How much punch will he have when he puts these two ingredients together? First, let's convert the fractional parts to common denominators. 8 and 4 have a least common multiple of 8, so we simply need to change the 3/4 into 8s. We can do this by multiplying both the numerator and denominator by 2. This will give us 6/8. Because we're multiplying by 2 over 2, which is another way of saying 1, we're not changing the value. Now we need to regroup. 8/8 equals 1. So if we add 3/8 plus 6/8, we will get 9/8. This is equal to 1 and 1/8. We will leave 1/8 with the fractional parts and regroup the whole number 1 into the ones place. 8 plus 1 is 9, plus 3 more is 12. We can regroup, and then we have 4 in the tens place. In this problem, 1/8 is already simplified, so we already have our final answer of 42 and 1/8 cups. In this lesson, you learned to add mixed fractions with unlike denominators by converting. In this lesson, you will learn to subtract mixed fractions with unlike denominators by converting fractional parts to common denominators, regrouping whole numbers into fractions, and simplifying answers using greatest common factors. You know that a whole number and the fractional part of a mixed number can be regrouped to create an improper fraction. For example, 5 and 3/8, the 5 can be regrouped. We'll take the 5 and create 48ths, along with the 3/8 that were already there. Altogether, the 48ths plus the 3/8 create 43/8. I'm going to explain the idea of subtracting mixed fractions with regrouping by first demonstrating that we can regroup in other ways. If we simply split 5 and 3/8 into 4 plus 1 plus 3/8, we can then regroup the 1 as 8/8. This creates 4 plus 8/8 plus 3/8. Altogether, this creates 4 and 11/8. We'll return to this 4 and 11/8 later, but first, let's look at a common denominator example. We'll return to our 5 and 3/8. From that, we will subtract 2 and 7/8. In order to regroup easily, we will rewrite the fractions vertically. Now, we will start on the right, much like other times we subtract using place value. It'll be easier to subtract the 7/8 if there are more 8s here in the fraction above it. We can regroup from the 5. Remember, 8/8 equal 1. So, if we borrow a 1 from the 5, That leaves 4 in the ones place. The 8/8 plus the 3/8 create 11/8. Now we can use this 11/8, subtract 7/8, and get 4/8. 4 minus 2 is 2 in the ones place. Now we will simplify using the greatest common factor. We can divide by 1 because it won't change the value. 4 over 4 is another way to write 1. We divide by 4 over 4 because it is the greatest common factor of the numerator and the denominator. We're left with 2 and 1/2 as our answer. Let's see how subtracting with unlike denominators works. We will need to convert the fractional parts to common denominators, regroup whole numbers into fractions if necessary, and simplify our answers using greatest common factor. In this problem, Linda had 17 1/6 ounces of clay and used 3 2 ounces to create a mug. We will subtract to find out how much she has left. We will start by writing the problem vertically. Then we will create common denominators. The least common multiple of 6 and 3 is 6, so we simply need to change the bottom fraction. We will multiply by 2 over 2, which is equal to 1, creating 4/6. Now we will look to see if we need to regroup. Because we are subtracting 4/6 from 1/6, we will need to look to the ones place to regroup. 6/6 equals 1, so we can cross out the 7, leaving 6, and add 6/6 to our 1/6. This will total 7/6. Now we can subtract 7/6 minus 4/6 equals 3/6. 16 minus 3 is 13. Now we will simplify the fractional part using the greatest common factor. The greatest common factor of 3 and 6 is 3. So if we divide the top and bottom by 3, we get 1/2. Therefore the answer is 13 and 1/2 ounces of clay. You just learned to add mixed fractions with